Building your dream. AI Workstation is an exciting journey that promises new creative possibilities, faster workflows, and the power to tackle cutting-edge projects. However, with a rapidly evolving hardware landscape, choosing the right components, especially the all-important GPU, can feel daunting for beginners and enthusiasts alike. Whether you're passionate about training machine learning models, experimenting with generative AI, or delving into massive data analysis, assembling the ideal workstation comes down to a thoughtful balance of budget, performance, and future-proofing. Let's embark on this beginner-friendly exploration of hardware selection, starting with the GPU, diving into performance versus cost, and covering the often overlooked essentials that ensure your AI system runs smoothly and efficiently. When it comes to AI workloads, the GPU, or graphical processing unit, often emerges as the superstar of the system. Unlike the CPU, which is geared for general computation and sequential tasks, the GPU excels at parallel processing, making it far more adept at handling the enormous datasets and complex mathematical operations intrinsic to artificial intelligence. However, not all GPUs are created equal, nor do you need the most expensive card on the market to get started. The right choice depends on your specific goals, expected workloads, and, of course, your budget. Begin by considering what you want to achieve with your AI workstation. Are you primarily planning to develop and fine-tune small-scale models, or dive into the intricacies of massive neural networks and deep learning projects? If your interest lies in learning, prototyping, or light experimentation, there's no need to break the bank. Entry and mid-level GPUs can deliver solid results, but if you envision yourself working with large datasets, complex deep learning frameworks, or running compute-heavy simulations, investing in a higher-end GPU pays dividends in training speed, efficiency, and flexibility. In the current market, two families of GPUs dominate the conversation: NVIDIA's RTX 40 series and AMD's Radeon RX 7000 series. Both have their strengths and weaknesses, and understanding these nuances will guide you toward the optimal card for your AI ambitions. Let's start with NVIDIA's offerings. The RTX 40 series, built on the Ada Lovelace architecture, continues NVIDIA's tradition of powerful, AI-focused compute performance. Cards like the RTX 4070, 4080, and 4090 boast impressive CUDA-core counts, high memory bandwidth, and support for critical AI frameworks such as TensorFlow and PyTorch. Importantly, NVIDIA GPUs benefit from the company's proprietary CUDA platform, which is widely supported in the AI community. This compatibility makes it easier to leverage optimized libraries and take advantage of ready-to-use, high-performance code. Additionally, features such as Tensor Cores, specialized processing units dedicated to speeding up deep learning computations, give NVIDIA cards a distinct edge in many AI workflows. The RTX 4070, for instance, offers excellent value for newcomers. With ample VRM, solid computational power, and widespread compatibility, it's well-suited for training moderate-sized models, engaging in computer vision tasks, and exploring natural language processing projects on a personal or academic scale. If your budget allows for more, the RTX 4080 and 4090 step up with even more memory and raw power, ideal for handling extensive datasets or developing large-scale generative AI models. Keep in mind, however, that these cards come with a significant price jump, and their formidable performance may be more than is necessary for beginners or those focused on smaller projects. Turning to AMD, the Radeon RX 7000 series ushers in impressive advancements of its own, built on the RDNA 3 architecture. Cards like the Radeon RX 7900 XT stand as compelling alternatives to their NVIDIA counterparts, often offering similar raw computational power and greater value per dollar. For AI workloads, AMD GPUs have made strides in recent years, especially with the development of ROCm, an open compute platform that aims to broaden support for frameworks like PyTorch. The RX 7000 series cards are typically more affordable for the given level of performance, a tempting choice for enthusiasts and those looking to maximize their budget. However, there are caveats to consider. AMD's ecosystem lags behind NVIDIA in terms of support for the broad range of AI software, documentation, and optimizations. Many machine learning tutorials, pre-built Docker images, and open-source libraries continue to be geared toward CUDA-compatible NVIDIA hardware. While this gap is closing, especially for Linux users comfortable with building tools from source, beginners may encounter a slightly steeper learning curve with AMD hardware when integrating with some popular AI workloads. So how should a newcomer balance performance and cost? Start by honestly evaluating your use case. If you plan on focusing primarily on learning, experimenting, or tackling smaller datasets, an RTX 4060 or Radeon RX 7600 could be entirely sufficient. Both cards deliver a strong entry point without excessive financial commitment. For those anticipating more advanced projects or professional workflows where time to results is crucial, investing in a higher memory card like the RTX 4070 Ti or Radeon RX 7800 XT would make sense. Remember that with GPUs, memory capacity, VRAM, is just as important as raw compute power. Models and datasets in AI can quickly overwhelm entry-level cards with limited VRAM, leading to frustrating bottlenecks or out-of-memory errors during training. While the GPU is often the star of the show, the supporting cast of components should not be neglected. RAM storage and motherboard choices are just as crucial for a balanced and high-performing AI workstation. Think of these as the foundation that enables your powerful GPU to reach its full potential. Let's tackle RAM first. Unlike gaming systems, where 16 GB is often plenty, AI workloads are memory-hungry. Especially when dealing with large datasets or running multiple processes. For most entry-level workstations, 32 GB of system RAM strikes a nice balance, providing the overhead needed for training models and running modern applications without excess. If you anticipate scaling up, perhaps wrangling very large datasets or working with multiple NVIDIA GPUs, 64 GB or even 128 GB can offer greater headroom and future-proofing. Fast memory, such as DDR4 or DDR5, further helps in minimizing data bottlenecks between the CPU, RAM, and GPU. Next, consider your storage options. Speed and capacity are both crucial. Traditional hard drives are too slow for the data-intensive tasks common in AI, so SSDs are the standard. An NVMe PCIe 4.0 SSD provides blistering sequential read and write speeds, drastically reducing loading times for massive datasets and minimizing delays when paging files in and out of memory. Aim for at least 1 TB of fast SSD storage to start. This ensures enough room for operating systems, datasets, frameworks, and your own projects. For larger or team-based workflows, supplementing with additional SSDs or even high-capacity hard drives for archival purposes can be a smart move. The motherboard, though less glamorous than the GPU or CPU, plays a pivotal role in ensuring your components communicate efficiently and reliably. For AI workstations, choose a motherboard that supports multiple PCIe 4.0, or better, PCIe 5.0, slots, enabling future GPU upgrades or the addition of extra high-speed storage. Check for adequate power delivery and thermal management features, since AI workloads can push hardware to its limits for extended periods. Opt for a board with a robust VRM, voltage regulator module, design, and sufficient cooling. Additionally, ensure compatibility with your chosen processor socket and enough RAM slots to support upgrades. Processor selection is another key consideration. For most AI desktop workflows, a modern multi-core CPU from Intel's 13th or 14th generation core processors or AMD's Ryzen 7000 series will be more than adequate. These CPUs offer strong general-purpose performance, fast I/O, and excellent multitasking capabilities. Since most of the heavy lifting will be offloaded to the GPU, the CPU's core count and clock speed are less critical than in traditional high-performance computing. That said, a reliable CPU is still essential for pre-processing data, running orchestration scripts, or controlling multiple simultaneous experiments. Power supply units, PSUs, are frequently overlooked but vital for system stability. High-end GPUs and CPUs demand consistent, clean power, especially under load. Invest in a high-quality PSU with an 80+ gold certification or better, and ensure it offers enough wattage and the correct power connectors for your GPU. For most single GPU builds, a 750 mAh 850-watt PSU is more than sufficient. If you plan to add multiple GPUs or a particularly power-hungry card like the RTX 4090, consider stepping up to 1,000 watts or more. Cooling is another important piece of the puzzle. AI model training can push your hardware to its thermal limits, sometimes for hours on end. Adequate case airflow, quality fans, and perhaps even liquid cooling solutions for both the CPU and GPU ensure consistent performance and prevent thermal throttling. Contain dust and manage cables well. Clean air, not just cool air, is essential for long-term reliability. Connectivity features count as well, especially if you'll be moving large datasets to and from network-attached storage or other machines. Consider a motherboard with 2.5G or 10G Ethernet, or add an expansion card as needed. Fast USB and Thunderbolt ports are a plus for connecting external drives or development hardware. Building your AI workstation isn't only about raw power, it's about crafting a balanced machine adapted to your unique needs and ambitions. Always leave room for future expansion, whether it's an extra GPU slot, more RAM capacity, or additional storage drives. The pace of development in AI is fast, but with careful planning and wise investments, your hardware can remain relevant and capable for years to come. In the end, your dream AI workstation is a tool, a springboard for your creative and technical aspirations. With the right GPU suited to your tasks and budget, complemented by fast memory, responsive storage, and a reliable supporting cast of components, you'll be empowered to push boundaries, experiment boldly, and bring your AI visions to life. And as the hardware ecosystem evolves, a well-built foundation ensures you're ready to upgrade, scale, and stay ahead in the world of artificial intelligence.